Hello, everyone. In this video, I will give a guide and tips for chapter 13 of my Java book. Chapter 13 introduces abstract classes and interfaces. So let's first look at abstract classes. In chapter 11, when we introduce inheritance and polymorphism, we use the geometric object class as example. So we have geometric object class as the super class for circle and rectangle. Now, if we write a method with the geometric object as the parameter, and we need to invoke the get area method, and we cannot do it because the get area was not defined in the geometric object in chapter 11. Well, let's define it. So we're going to define the get area and get perimeter in the geometric object class. So we can write that kind of code, but the problem is we cannot implement it because we don't know exactly the shape of the geometric object. So now comes this concept of to make it abstract. So we just make it abstract. We just provide the signature of the method in the geometric object class, and we're going to have the subclass of the geometric object to actually implement this abstract method. So the class has abstract method, and we need to make this the class also abstract. So when we declare this class in the code, so we have to use this keyword abstract for this abstract class. And now, and this is abstract method for this get area and abstract get area, and this is the abstract for get perimeter. So we have the method defined here, but there's no body for it. In the subclass, in the circle class, so circle extends geometric object. So here we're going to have to provide the implementation for this, and this is a get area. All right, so now let's see the benefits of using abstract methods through this example here. This is a test geometric object. So in this class, we have the method equals. So here's geometric objects. This is object 1, and here this is object 2. So when we implement it, and we're going to have this object 1 dot get area equals object 2 dot get area. So we're going to compare the two objects' area to determine whether they are equal. So if their areas are the same, and then they are considered as equal. Now, if you do not have this get area defined in geometric object, so you cannot write this kind of code. So using the abstract method in the abstract class, and we can write the more flexible code. we can do more useful things. All right, so the next section here is some of the detailed things we need to point out. It's so some interesting points about abstract classes. And now we're going to introduce the abstract number class in the Java API. And the number class is the super class for double, float, long, and all this wrapper classes, the primitive data type wrapper classes, and also for big integer and big decimal. All right, so next section, we introduce the calendar class and the Gregorian calendar class in the Java API. So Gregorian calendar is the concrete subtype of calendar. Calendar is abstract class. So there are different types of calendars. We use Gregorian calendar. That's normally that's the one we're using. And there are other calendars in the world. So there's lunar calendar, and there's also Jewish calendar. So all this can be considered as a subtype of this calendar class. So here, we look at this in the calendar class, and we have the abstract method at a specified amount of time and to the given field. So this is in the calendar. So this is the concrete implementation for Gregorian calendar. So there's the constants defined in the calendar class to retrieve the properties from a calendar. So year, month, date, and etc. All right, so the next thing we're going to look at is the interface. So interface is a class-like constructor for defining common operations for objects. So when you use abstract class, so here you define the some features and common features. You have all the methods there, and sometimes the methods are abstract because you cannot implement it. But for interface, it's more flexible. You can define common operations for different types of objects. So not necessary to be one kind of object. It can be different kinds of object. So this is the interface. So for example, here, we're going to define the interface edible. So you can have like fruits are edible, and some of this, fish so is edible, and some other things are edible. So that doesn't have to be the same kind of object. So, and for edible, and they have a common behavior is how we're going to eat it. So this is the abstract method to define in edible. So here's the keyword interface to define the interface. So it's pretty much like a class. You use it like class when you compile it, and you have a .class file. And this, here's an example here. When you have interface, you have to implement interface. So here we have chicken implements edible, and chicken is also extends animal. So animal is abstract class. So in this animal abstract class, we have this is sound. So what's a sound of animal? So here chicken as this animal is a supertype of chicken, and edible is also a supertype of chicken, but edible is interface, so it's implements. And so how to eat, so that's the override how to eat in the edible interface. And here the sound, and here this is how to make a sound for animals, so that is in the animal class. All right, so there's one important interface we need to mention here is the comparable interface. It's defined in the Java API for comparing two objects. So this is the comparable interface defined in the Java API. You can't compare with another object of the same type here. So you have this it is a lot of classes in the Java API implement the compatible interface. So integer. So here's compared to how you compare it. So this compared to method returns an int. So indicating and whether this object you compare is greater than, equal to, or less than. So this is integer will return a positive, 0, or a negative value for this. So this is, and here's a big integer. So here extends number, implements comparable big integer. Here's a string, extends object. So implements comparable string, another string compared with another string. Here's the date. So it's a date, it's implements comparable date. And here this is to compare two dates. All right, so this is the comparable interface. And there's another interface is called a clonable interface. So you can clone an object. So this is the clone interface. Clonable interface, it's called a marker interface. It doesn't have a method in clonable. So the previous one, the comparable interface, it has a method compared to, but this clonable does not have any method in it. So this is it's called a marker interface. So if you have a class that implements clonable, so the objects of class are clonable. So they are clonable. So actually, how you're going to clone it is this: you have to implement the. So let's go down to look at this house here. This is the house. So house is going to implement clonable. So here is how you're going to clone it. So you're going to write the code. It's called a clone. So here is the clone method. It's actually clone method is also defined in the object class, but in the object class, the clone method is protected. So you not have to make it public. So this is all you need to do clone. It's a return super.clone. So this, by doing this, and you use the default mechanism for cloning objects in the Java virtual machine. This one actually also has this compared to. So the house is actually also implements another interface. It's a comparable interface, as you see here. A class may implement multiple interfaces. Now, there's one thing I want to mention is for this, the clone, the default behavior is a shallow copy. You just copy the data fields. So clone the data fields. For some, the object that fails, and you need to perform a deep copy. So here is the issue with a shallow copy and deep copy here in this section. It's also discussed. All right, next here is to look at the differences between interfaces and abstract classes. So here's a table and more detailed discussion after the table. And now we use a case study to design a rational class. So we have the wrapper classes for numeric data types, and we have the also have big integer and big decimal for large numbers, and for rational numbers. And we are going to design our own class. So we make this design design the rational as the subtype of number and also interface. So rational is going to extend number and implements a comparable interface. So this is the rational. It's the design UML diagram, and this is to test it and how we're going to use it, provided it's already implemented. And finally, we're going to see actually how we implement the rational class. And now this section 13.10, and we kind of give this design guidelines for object-oriented design. So here's all the things: cohesion, consistency, encapsulation, clarity, completeness, instance versus static, and so a lot of more here. So all this here. And now we'll get into the last thing is in this chapter. We're going to introduce records. So records is new feature introduced since JDK 1.14 as the Java 14. So before record, and when you representing a record, you define a class with all data fields and some of these methods and constructors. And now you can use a simple one-line code and just call this record. The teacher has a name, has a birth date, and has a weight. So this one-line code is equivalent to you write this many lines. So it really simplify the way you represent a record. So and the way you use it, and use a record is just like you're going to use the regular class with some default features. So it's very convenient and to write code and using record now. That is all for this chapter 13, abstract classes, interfaces. Thank you for watching. Goodbye.